This video is on one variable statistics. So what we're going to do here first is we're going to say what's to be done, and we're going to go through that rather quickly, and then we'll go through one example so you can see how that actually plays out, and then we'll probably use another video to do a second example. With one variable statistics, we determine our best estimate of the true value of some measurement or result, as well as our level of confidence in our conclusion. For our work, we will need the mean, the standard deviation, and the standard error based on the multiple values that we have for some quantity. So here are the steps. We're going to determine the mean by adding all results and dividing by the number of them. You learned how to do that in what? Third grade, fourth grade. Number two, we're going to determine the standard deviation, which is often shown on calculators as S sub x. And we're always going to use this S sub x and never the slightly different sigma sub x. So there's an equation for that. Here it is, but it's easiest to use a calculator, and that's the way that I'm going to show you. Once we've found the value of S sub x, then we want to calculate the standard error, which is this S sub x divided by the square root of the number of data points that we have. And we're going to report our answer as the mean plus or minus the standard error and then whatever the unit is. And here's the rule for significant figures. The standard error, which is a measure of the confidence we have in our results, will always have one significant figure, and the mean should be reported to that place value. So let's show you how this works. Suppose we have a class of physics students that took some pendulum measurements in the lab, and each group determined an experimental value for the acceleration due to gravity, g. The class's data is shown. Report the class's best answer as to the value of g in meters per second squared. So it looks like we had 9 groups, and they did some measurements and determined the value of the acceleration due to gravity g as these values here. And as a whole, we want to say what's the class's best estimate about what the value of g is. So what we're going to do is we're going to count up the data points, 9 of them. You can see that there. And then we're going to put these values into our calculator. And I've already done that, but on a graphing calculator, on a TI, this is how it's done. You want to go into stat mode. First, you want to turn your calculator on. Then you go into stat mode. And here we're going to edit. We need to put numbers in. So I'm going to hit enter there. You can see I've already entered those 9 data points here in the first column. So you do that first. Then you quit the stat mode by hitting second, and then the quit button is above the mode key. Now we want to go back into stat, but now we want to calculate. So I need to toggle to the right to calculate, and there are several choices, and the one we want here is actually the first one. So I'm going to hit enter, and it's going to give me some choices. I've put my points into the first column, so it's all good. I'm just going to hit enter a few times here, and there we go. So what this is telling us is that the mean is 9.837, and I'll just put that as repetin 7. Then we said we wanted to find the SX value, which you can see here is 0.082. So that's what we need from our calculator. The standard error then is calculated from this SX value. So the standard error is SX divided by the square root of n. So that's going to be 0.082 divided by the square root of 9, which is obviously 3. And we want to report the standard error to one significant figure, which in this case, you could try it yourself, is 0.03. So our final answer then is going to be the mean rounded to this decimal place. So now you can see the mean over here. So our best answer is going to be that our physics students decided that g is going to be 9.84, rounded to the hundredths place, plus or minus 0.03 meters per second squared.